Good morning students, myself Dr. Susan Ram Kumar, Associate Professor EC Department. Today we are going to discuss about our third unit, FIR filter in discrete time signal processing. So first of all, we go for see about the FIR filter. So FIR means finite impulse response filter, or often non-recursive type, where the present output samples depends on the present input sample and previous input samples. So we can say that FIR is a non-recursive because the output sample depends on the present input and also the previous input samples. Advantages: FR filters have exact linear phase and are always stable. FR filters can be realized in both recursive and non-recursive structures. They can be realized efficiently in the hardware. And disadvantage of FR filters are the implementation of narrow transition band FR filters are very costly, as it requires considerably more arithmetic operations and hardware components such as multipliers, adders, and delay elements. Memory requirements and execution times are very high in FAR filter. So this is the difference between the FAR and IR filter. In our discrete time signal processing, there are two types of filters we are going to study. One is infinite impulse response filter, and one is finite impulse response filter. So now we are going to see about the difference between the FAR and IR filter. In FAR, these filters can be easily designed to have perfectly linear phase. IR filter, these filters do not have linear phase. And in FAR filters can be realized recursively and non-recursively. IR filters are easily realized recursively. FAR filters greater flexibility to control the shape of their magnitude response. IR filters less flexibility, usually limited to specific kinds of filters. And then FAR filter errors due to round off noise or less so in FAR filters, mainly because feedback is not used. IR filters, the round off noise in IR filters are more. So now we go for see about the what are the different methods for designing the FAR filter. In FAR filter, we have design in three different methods. First one is Fourier series method, second one is window technique, and third one is frequency sampling method. So this is the frequency response of ideal filters. First one is low pass filter. In low pass filter, we have the same characteristics in the negative and the positive regions. And second one is the high pass filter. In high pass filter, we have the republic characteristics in the omega c pi and minus omega c and pi. And then we go for the band pass filter and band stop filters also.